Welcome to a Protobuf tutorial, and this tutorial is very specific to Protobuf that's been used by Eclipse Kapua. That's a MQTT broker, and when it receives data, it decodes. It expects a Protobuf structure. It decodes it, and then it can persist it in its database, and you can visualize it in its UI. But if you send it in a normal JSON structure, or you just send raw data, then Kapua won't be able to process it. But it will still send it, but it won't persist it or show it in its UI. So Kapua uses this protoc structure or protobuf structure. Now, what is protobuf? Protobuf is exactly the same as JSON. You know, JSON you can have multiple values and things like that. JSON is, I would say, more beautiful for you to look at. While Protobuf is a binary version of it. It's more beautiful to the computers, I guess. Yeah. So what's the structure of a protobuf? We'll just go through it now. So this protobuf structure is specific to Eclipse Kapua, right? It's made up of 3 basic components. When you send a message, you can have a timestamp, or you can have Kapua position. For example, here, this is a message structure for it. You can have all this information regarding the device that's sending it. And then the one that's being used most is, it's called a Kura matrix. So it's a repeated function, so you can think of it as sending an array of values. And how many values can you send? About 5,000. So what makes up a Kura matrix? It's made up of any of these values. So for example, if you want to send a temperature, you would send a Kura matrix with name temperature. What type is it? It may be a double type, 25.3 degrees, and send, for example, humidity. So you'll send another Kura matrix with name humidity, and again it can be double, and then you can have another matrix, for example, number of plants. So name will be number of plants, the data type will be maybe int32, right? So you can build your number of Kura matrix, and like I said, up to 5,000, right? So I'm just going to explain to you only timestamp and Kura matrix. Kura position, you actually can do it in a Kura matrix. You just send one Kura matrix for latitude, one for longitude, one for altitude, right? It's up to you. So there. Once the message structure is already defined by Kapua, right, then what we can do is you can just download protoc, and then you can run this command that will generate the class files, for example here Java, but you can also do it for Python and C++, C, all the other types of programs, and then you can just use the class names and the libraries. But what all the libraries are doing, it's the same thing behind it. It's just manipulating the binary stream. So what I'm going to explain to you now is what actually happens, what's going on behind the libraries. And it's very simple. Yeah. So let's see. For example, this is a Python script, and it generated that kurapayload protobuf file. and then I can call it here. I can create a matrix type of example int32. I can put the value 42, and I can just call these functions, right? And then at the end of it, everything is put into a serialized string. So basically byte data, right? So I'll explain this a bit more. So let's get into it. So the first thing about Protobuf, we're going to decode a timestamp, right? So for example, this actually should be encode. So first thing is we want to send a timestamp. That's the value, the Unix value. I think it was started in 1979. I wasn't there. And then this value is is in milliseconds. And first thing we do, convert it to binary. This is the most significant bit, least significant bit. I'll tell you why it's important. The first step we need to do is we need to split up this long binary into 7 chunks, 7-bit chunks. An example there, and you continue 7 bits, 7 bits, 7 bits, 7 bits, 7 bits until you come to the last one, and you append zeros to make it 7. So for example, this is 6, but we need 7, and we have 7 there. I'm just going to put them, yeah, I like this. Yeah, so 6, 1, 2, 3, 4, 5, 6. 6 over here, put a 0, so all are 7. Then the next step, what we do is we need to rearrange them. So this was the most significant, this was the least significant. Now we're swapping the bytes around, and the most significant byte becomes the least significant byte, and so on and so forth. So we're just swapping them. Now these are 7 bits. We need to make them 8 bits. What we do is, the first one, we add a 1. This is for the decoder to know that if this is a 1, means that there's another byte that makes up the full value. So it reads this, there's a 1, oh, there's more to the value. Okay, the next one still has a 1, there's more to the value. There's a 1, there's more to the value. So you add a 1 in front of all of the 7-bit chunks that we made, except for the last one, which we put 0. So how the decoder will go, 1, okay, there's another byte, 1, there's another byte, 1, there's another byte that makes up the timestamp, 1, another byte, 1, another byte, 0. Ooh, this is the final byte that makes up this number. So it's purely for the decoding part. Then then we take this value and get the what's it called, hex values there, and that makes up the encoded value, and we just put a 08 in front. This is Kapua's way of saying that there's a timestamp, because like we said, timestamps are optional. This is the byte that gives or tells the decoder there's expected timestamp. Now this is actually supposed to be the decoding part, right? So let's assume that we sent this protobuf message. So forget about this word. We sent this message, it's encoded. This is the actual value. We're just going to check again what I said. This tells the decoder that there is a timestamp value, and then all I did is expand all of these into binary, right? That is telling the decoder that there is a timestamp. Now we need to reverse the process of the encoding. We take the timestamp data. What we do is we remove the first digit, because this is telling us when to stop. We remove the digits, we're left to the 7-bit numbers, Right? Then the next step what we do is we reverse the order, because encoding we swap them, decoding we swap them back. There, and then getting the value of this in terms of decimal, we look at that. You can check it out in the calculator, and that matches that. Right? So this is the simple Python code that does it. All I'm doing is I'm creating a Kura variable called publish. That's supposed to be H. Don't worry about that. Publish message dot timestamp the time multiplied by 1000, because Kapua needs it in milliseconds, and then the data is in. To read it out, we'll just print it out via serial to string. Very simple. There. Now in 32, this is an example of an encoded message, right? How do we read this? The first thing that we noticed is the first one is 08. That's because we've got a timestamp there, and then we have the value of the Unix time. Then the second thing we need to add is called a matrix tag. So I should have put the word matrix here, but this is a matrix tag. It tells the decoder that now there's a matrix that's starting. The next byte is how many bytes this tag, this matrix tag has, right, in total after this byte. So not including this byte. So this D is 13, yeah. So 13 is 13 bytes after this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the decoder knows that after this tag, matrix tag has 13 bytes after this. Then 0A means that this is a tag that says it's the start of the label name. So for example, it can be temperature, you can call it humidity, it's up to you. The next byte is how many characters are there in the label, right? So how many 8-bit, how many bytes there are. So in this case, 04 hex, which is same as 4 bytes. So the next, how many bytes there are? 4, 1, 2, 3, 4. That's the label name. And it's the ASCII byte value. And in this case, if you know your ASCII table, it's A, B, C, D. So we're sending a label A, B, C, D equals, and this is the tag that tells, this is the data type tag. And what we're telling the decoder that for this matrix, the data type is int 32. There. Good. Now, then after that comes the actual data. Now, here, how do we create the data? It's very simple. It's pretty much the same as the timestamp. So how do we do that? Just for example, just so you know that this representation here is actually this number. If you take this and you convert it, you're not going to get this number because there's that same trickery that's involved. How do we encode the 32? First step is just like timestamp, we convert it to binary. More significant, we break this up into 7 chunks, append zeros to make the last one 7, and then what we do is we swap them around, and then we add 1 in front, except till we reach the last byte and we put a 0. Again, this is for the decoder to know that 1 when to stop, when is the last byte that represents the data. When it says 0, that's it. And if you take this value here, you create, this is F7, B0, B9, B7, and sorry, 07, and that's the encoded data, right there. Now, like I said, you can have multiple matrix. And how does the decoder knows? It looks for these tags. Okay, so this is an example of I'm sending two matrix values of int32, and this is the whole thing. Again, we recognize timestamp 08 and this guy here, and this is your start of your matrix tag, and it's very easy. The more you do this, the more you see it. It's C2 B802. For me, this is like a curly brackets in my head, right? And then again, how many bits, how many bytes there are for this tag, start of the label, how many values in the label, and then the label itself. In this case, it's same like before, A, B, C, D. Then this is the tag. What type is it? If you remember, 100330 is int32, and then the actual value, just like last time, it's this value. Then when it sees C2B8C2, this means a start of a new tag, and the new tag that we're making for now is FGHI, and it follows the same suit. That's the tag, number of bytes that this tag belongs to. A means the start of the label, how many characters are in the label, FGHI. So if you know your ASCII, FGHI, then the data type, and then the actual data, which is this number, which is like 1 less than this. Just for simplicity's sake, you can see F6, F7, F6, it's just 1 less. Yeah, that's it. So, I messed up the E. Yeah, it's fine. So 41, 42, 43, 44, then 46 is H in ASCII. So like this, you can build a matrix as many as you want, up to 5,000. The name of the length of the name can be anything that you want, and the data values can be, of course, anything what you want. Yeah, one of the things is that Protobuf actually, it reverses the order. So if you send, for example, like a 0 value, then you will only take like 1 byte, right? That's why it puts it in the reverse order. It kind of like allows it to be compressed quite nicely. Now, this is the code to do it. So I created one matrix with ABC and the value here. Then I created another matrix with, I named it FGHI, and then I got that value, which I hard-coded it for now. Good. So next data type that's used all the time is double. Now what I'm going to create is a message that says ABC equals that, and I'm going to put this into a protobuf. Now you guys should be nicely able to see a timestamp. Yeah, I see it. I actually don't even see the binary. I see the structure now. There, that's the timestamp that it does. We know C2B802 is the start of the tag. How many bytes that make up this tag? A3, 0A means start of the label. 03 means how many characters are in the label, 3, and then the actual label, A, B, C. Then the next one is this is the tag, that the data type tag, and it's 10 0019 means double. And here's the double value. So it's this value that's encoded. When you encode it, you get this. So if you take this value, you go to an online converter, it's not going to give you the same number. How do you encode this value into this? It's very simple. Another thing is that good thing about double is it's a fixed length, so it's 8 bytes. So no matter if it's a huge number or if it's a small number, the size is the same, unlike int32 where the size can be variable. There, I explained that. How do you get the value? First, how do you get from here to this encoded value? You take this number and you perform a double to binary conversion, right? So there's no tricks, nothing. You can follow an online tutorial. How do you take a double number and write it out in binary? It's standard. There's no adding zeros, there's no swapping anything for now. You just write it out there. So this guy here in hex is this value here. Now to convert it into what Protobuf understands, all we do is we swap the order. So most significant bit becomes least, and so on and so forth. So that becomes there, that moves there, and so on and so on. This becomes the most significant bit, and that's how you get this number here. So it's basically read in reverse, but not reversed in bit form, it's reversed in byte form. Yeah, so 40 becomes least significant 40. That's double, quite nice. String is even easier. Here's an example of a string. We all recognize timestamp by now. Then start of a tag. Then the next one is how many bytes does this tag have? It's 31. It's going to take long to count. Trust me, it's there. You can pause and count. A0A means start of the label. 08 means how many characters are in the label. And in our case, it's 8, 1, 2, 3, 4, 5, 6, 7, 8. There. Then the next one is the data type. So we're saying it's the data type 10.05.42 means string. And then after that, how many bytes there are in the string. So how many bytes are there from this point here onwards? 17, again it's long, you can count it, it's right. And there's a ASCII table just so you know what I was writing here. So Q is 71, U is 75, etc., etc. So there's no swapping here, there's no least bit to most bit. For string, it's straightforward. You take the text, convert it into 8-bit, and then you sequence it like that. So that is string. Now, here's an example. If you made it this far and you're still watching, then you've got some Protobuf problems. And hopefully it's solved by now. So this is a full example of a huge string that has multiple metric values. So like the first thing you see, 08 means timestamp. So we have a timestamp. After that, C2B802 is your start of a matrix. It's 14 bytes long. That is the start of the label. How many characters are in the label? That's the label. Then the data type 10.0330. It's int 32. Then the int 32 value A2. What is A2? We'll find out now. Yeah, it's 42. So what I wrote here is answer to life, and the value is 42. Those that know why it's 42, you know why. Then the next tag is C2B802. Like I said, start of the next tag, how many bytes in the tag, start of the label, how many characters in the label, the actual characters that make up the label. Then 10, 0, 2, 0, sorry, 10, 0, 5, 42. We know this is the string type. How many characters are coming in the string? 4. That's the 4 string. What does this message mean? It means this guy here. Pluto is a planet equals yes. That's obvious. We didn't need Protobuf to tell us that. Yeah, Protobuf is true in terms of facts. So then the next one is C2B802. Start of the next tag. What is that? How many bytes? Start of the label. How many bytes in the label? That's the label value. And then 100019 is, what is that? 100019 is, what's the thing called? What's the thing called? With the comma, with a dot. Double. There, double value, and like I said, double value is 8. What does this message mean? If you break that up, amount pizza I share in a percentage equals 2 to the power minus 3, so 0.002. So yeah, Renal don't share. Then next tag comes up there, start of next tag, how many bytes in it, start of the label, how many, what's that thing called, how many characters in the label, that's the label, that there is the data type, so in this case it's double again, that's the double value. What was this? Fish. I was just testing the double. Yeah, so fish 11, the original value was 11,00212, and that's it there in when you use an online converter. Then the next one is that tag, 12 bytes long, not 12 is a hex value, so you convert that to binary, sorry, into decimal, how many bytes are afterwards. 0A is how many, so is start of the label. 0C is how many bytes the label is, that long. Yeah, so this is the label. What is C? 14. A, B, C, D. D, I think it's 12. Yeah. Oh, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ah, yes, 12. And that is, what is that? 10, that's, sorry, that is in 32. Like I said, I don't see hex, I see the type. And then 03. So if you convert, this message is lucky number equals 13. So this is a Protobuf for Kapua that has a timestamp and these data being sent. So if you want to, there's a situation where the libraries didn't fit in a PLC that I was using, so I had to manually get the data and put it in there because the Protobuf C library was too large. So if you ever come into this situation and you're working with Kapua, this is how it looks. It's quite beautiful. Hope you enjoyed. Any questions, put it in the typing bottom place that's below this, and I'll get back to you. I don't know 100% Protobuf, like I don't know why it's 10.05.42, why that's there. I just know it's there. Okay, thank you. Thank you. Come again.